Assalamu alaikum. Today we will study wind energy. What is wind? Wind is the stabilization movement of air between areas of high and low atmospheric pressure created by the uneven heating of the earth's surfaces, land, water and air. The greater the pressure distance difference between these areas, the harder the wind blows. Wind also exists as the circulation of air around a high or low pressure area. What is wind energy? Wind energy is the converting of wind power to electrical power through the use of windmills or turbines. The electricity produced is sent to transformers where voltage is increased and sent to the power grid via transmission lines. Wind energy, where it comes from. All renewable energy except tidal and geothermal power ultimately comes from the sun. The Earth receives 1.74 multiplied by 10 power 17 volts of power per hour from the sun. About 1 or 2% of the energy is converted to wind energy, which is about 50 to 100 times more than the energy converted to biomass by all plants on the earth. Differential heating of the earth's surfaces and atmosphere includes vertical and horizontal air currents that are affected by the earth's rotation and contours of the land. Wind example: land sea breeze cycle. Historical overview: wind has been used by people for over 3000 years for grinding grain and pumping water. Windmills were an important part of life for many communities beginning around 1200 BC. Wind was first used for electricity generation in the late 19th century. Grand Pass Noob. First point, Smith-Putnam machine. Second, 1941. Third, Rutland, Vermont. Fourth, 1.25 megawatt. 5, 53 meters, largest turbine for 40 years. 6, structural steel. 7, lowest blade in 1945. These are the all features of Grand Grand Pass Noob. Windmill design. A windmill captures wind energy and then uses a generator to convert it to electrical energy. The design of a windmill is an integral part of how efficient it will be. When designing a windmill, one must decide on the size of the turbine and the size of the generator. Wind turbines, large turbines, able to deliver electricity at lower cost than smaller turbines because foundation cost, planning cost, etc. are independent of size. Well suited for offshore wind plants. In areas where it is difficult to find sites, one large turbine on a tall tower uses the wind extremely efficiently. Small turbines. Local electrical grids may not be able to handle the large electrical output from a large turbine, so a smaller turbine may be more suitable. High cost for foundations for large turbines may not be economical for some in some areas. Landscape considerations. So it is landscape consideration. Wind turbines, number of blades. Most commonly designed is the three-bladed turbine. The most important reason is the stability of turbine. A rotor with an odd number of rotor blades, at least three blades, can be considered. A rotor with an even number of blades will give stability problems for a machine with a stiff structure. The reason very is that at the very moment when the uppermost blade bends backwards because it gets the maximum power from the wind, the lowermost blade passes into the wind shade in front of the tower. These are the three blade turbine and it is very good for stability. Wind turbine generators. Wind power generators convert wind energy to mechanical or electrical energy. The generator is attached at one end to the wind turbine which provides the mechanical energy. At the other end, the generator is connected to electrical grid, the generator needs to have a cooling system to make sure there is no overheating. Small generators require less force to turn than a large ones but give much lower power input. Less efficient. Example, if you fit a large wind turbine's rotor with a small generator, it will be producing electricity during many hours of the year, but it will capture only a small part of the energy content of the wind at high wind speed. Large generators, very efficient at high wind speeds but unable to turn at low wind speeds. Example, if the generator has large coils and or stronger internal magnet, it will require more force mechanical to start in motion. Other design considerations. First, winds are influenced by the ground surface at altitude up to 100 meters. Wind is slowed by the surface roughness and obstacles. Third, when dealing with the wind energy, we are concerned with surface winds. For a wind turbine, obtained is its power input by converting the force of wind into torque turning force acting on the rotor blade. 5. The amount of energy which the wind transfers to the rotor depends on the density of the air, the rotor area, and the wind speed. The kinetic energy of a moving body is proportional to its mass or weight. The kinetic energy in the wind thus depends on the density of the area, its mass per unit of volume. In other words, the heavier the air, the more energy it received by the turbine. At 15 Celsius, air weighs about 1.225 kg per cubic meter, but the density decreases slightly with increasing humidity. Other design consideration. A typical 600 kilowatt wind turbine has a color as has a rotor diameter of 43-44 meters. Example, a rotor area of some 1500 square meters. The rotor area determines how much energy a wind turbine is able to harvest from the wind. To be considered a good location for wind energy, an area needed to have average annual wind speed of at least 12 miles per hour. A windmill built so that it too severely interrupts the airflow through its cross section will reduce the effective wind velocity of its location and divert much of the airflow around itself, thus not extracting the maximum power from the wind. At the other extreme, a windmill that intercepts a small fraction of the wind passing through its cross section will reduce the wind's velocity by only a small amount, thus extracting only a small fraction of the power from the wind tra- tra- traversing of the windmill disk. Modern windmills can attain an efficiency of about 60% of the theoretical maximum power of wind. The power in wind is proportional to the cubic wind speed v cube. Why? Kinetic energy of an air mass is proportional to v square. Amount of air mass moving past a given point is proportional to wind velocity v. Cost calculations. A typical 600 kilowatt turbine costs about 4,50,000 dollar. Installation. Installation costs are typically 1,25,000 dollar. Therefore, the cost will be about 5,75,000 dollar. The average price for large modern wind farms is around $1,000 per kilowatt electrical power installed. In modern wind turbines are designed to work for some 120,000 hours of operation throughout their design lifetime of 20 years, 13.7 years non-stop. Maintenance costs are about 1.5 to 2.0% of the original cost per year. You can stop, you can pause the video and read this carefully. Wind power resources areas, you can see these are the wind power, and it is the largest, and it is the no, it is the largest. Red area is the largest, but I can't see red area in the map, so you can pause and look at it carefully. You can also pause this slide and read it. Now we will study advantages of wind power. The wind blows days and night, which allow windmills to produce electricity throughout the day faster during the day. Energy output from a wind turbine will vary as the wind varies, although the most rapid variations will to some extent to compensated for by the inertia of the wind turbine rotor. Wind energy is a domestic renewable source of energy that generates no pollution and has little environment impact. Up to 95% of land used for wind farms can be used for other profitable activities including ranching, farming and forestry. The decreasing cost of wind power and the growing interest in renewable energy sources should ensure that wind power will become a viable energy source in the United States and worldwide. When the wind doesn't blow, two fossil-fired generating units have to be kept running on a standby basis in case the wind dies down. No wind speeds rise and fall gradually, and the system operator has time to move other plants on and offline as needed. A 100 megawatt wind plant requires about 2 megawatt of conventional capacity to compensate for changes in wind. Wind can reliably provide 20% or more of our electricity. Lifetime environmental impact. Manufacturing wind turbines and building wind plant does not create large emissions of carbon dioxide when these operations are included. Wind energy CO2 emissions are quite small, about 1% of coal or about 2% of natural gas per unit of electricity generated. Noise. Noise used to be a very serious problem for the wind energy industry, annoying from as much as mile away. Aerodynamics and soundproofing have been improved significantly. Wind turbines operate when the wind is blowing, which tends to be louder than turbine noise. A modern operating wind farm of distance of 750 to 1000 feet is no noisier than a kitchen refrigerator or a moderately quiet room. Shadow flicker. A wind turbine's moving blade can cast a moving shadow on a nearby residency depending on the time of the year and time of the day. Normally, it should not be a problem in the US because at US latitudes, except in Alaska, the sun angle is not very low in the sky. Electrical power quality. Generally not a concern for low penetration. Weak grids are weak grids and grid reinforcements. Problems may occur in a turbine is connected to a weak electrical grid which can be reinforced. Power quality problems caused by the wind farms are the exact mirror image of connecting a large electricity user. Example, a factory with large electrical motors to the grid. Electrical flicker. Flicker is equals to short-lived voltage variations in the electrical grid which may cause light bulbs to flicker. Flicker may occur if a wind turbine is connected to a weak grid. Flicker can be reduced with proper turbine design. TV and radio reception. Modern small residential wind turbines will not interfere with communication signals. The materials used to make such turbines are not metallic composites, plastic, wood. Small turbines are too small to create electromagnetic interference (EMI) by chopping up a signal. Large wind turbines can interfere with radio or TV signals if a turbine is the line of sight between a receiver and the signal source. Alleviate the problem by improving the receiver's antenna, installing the relays to transmit the signal around the wind farm. Saint Paul Island, Alaska. Turbine size 2 to 5 kilowatt. Turbine manufacturer Vestas. Developer owner Northern Power Systems. Capacity 225 megawatt. Morehead, Minnesota. Turbine size 250 kilowatt. Turbine manufacturer NEG Micon. Developer Sporehead. Public service. Capacity 75. Sizes and applications. Small, lower than or equal to the 10 kilowatt. Homes, farms, remote applications. Intermediate 10 to 250 kilowatt. Village power, hybrid system, distributed power. Large 660 kilowatt to 2 plus megawatt. Central station, wind farms, distributed power, community wind. Drivers for wind power. Declining wind costs, fuel price uncertainty, federal and state policies, economic development, green power, energy security. So this is for today. Inshallah, we will meet soon in new lecture. Allah Hafiz.